Hello everyone. Welcome to this session as part of the Cloud Native Data Management Day co-hosted with KubeCon North America 2021. My name is Hrishi Keremane. I'm a Senior Product Manager for NetApp Astra. In this session, we're going to cover some of the trends that are influencing the data services architectures for the modern applications and Kubernetes workloads. Before we get into the data services, let's look at the NetApp Astra portfolio as a whole. We look at it as two different buckets. We have the control plane and the data plane. The control plane consists of Astra Trident, which has been out there for a while, which is our CSI driver allowing auto provisioning of volumes. Astra Control is built on top of it to provide end-to-end app data lifecycle management. Both of these are available on-prem as well as in the public cloud. We do have a CNDM Day session, and I encourage you to attend this by my colleague Shayan Saha on Astra Control Overview. This session is going to focus on Astra Data Store, which is our data plane, purely Kubernetes native data services for your cloud native applications. So before we get into the data services and innovation that Astra Data Store provides, let's look at what are the drivers for these storage innovations. If you look at it, we believe that application modernization is driving infrastructure modernization. And this is evident if you look at the paradigm shifts that have, and this applies to both compute and data platforms. And if you just look at compute, you have witnessed the paradigm shifts between going from a monolith with dedicated hardware to virtualized environment where apps run on or leverage the entire data center's resources to the cloud, which brings in scale on demand capabilities, right? With Kubernetes, which now allows you to seamlessly build scalable apps using declarative APIs while you're abstracting the underlying infrastructure altogether. Now, this also means that there are innovation that this drives at the data platform layer, and it's kind of followed suit. If you think about in the physical world, resiliency was the key to avoid single points of failure so that your business critical applications would be always available. And in the VM world, storage platforms or data platforms had to be re-architected for hard performance to overcome the I/O blender problems that the app density brought. Right. So, and this continued. We had to bring in distributed data platforms to meet the scale of your applications in the cloud. And now with Kubernetes, it actually means dynamic volume provisioning, being able to provide these services that microservices which can run on any of the worker nodes demand. So before we get into the specific services, let's look at what has been the adoption of data on Kubernetes. And some of the workloads, the rich data workloads which are driving this adoption are, and I'm sure most of you have worked on one or many of these, are the IoT data pipelines, the AI/ML pipelines, CI/CD, databases service, and so forth, right? And all of these are kind of built on top of data as the backbone for its operations. Right? And if you're providing one of these services, I'm sure you're thinking how to scale, share, and secure this data. And it's kind of evident in the recent CNCF survey where 50% or more of enterprises said they're already deploying their production stateful applications in containers. So what does this mean? We believe that for your cloud native applications to be sophisticated and meet the business needs, you need a shared file service while continuing to retain enterprise grade maturity and data services that the applications are used to. And let's kind of peel into what each of these mean. Let's look at shared file and what are the benefits of that an application gets from a shared file access. So in this particular example, I mean, you're familiar with PVs, right? The pods getting your dynamically provisioned PVs. But Kubernetes also provides flexibility for applications to actually request PVs with certain capabilities, including asking PVs with shared access through multiple pods. And that's the shared file access, the shared PV. Now, what does that enable? Like, let's look at a very common pipeline that we talked about as one of our common workloads, right? So data is passing through these different stages. It gets cleansed, transformed, enhanced, right? But each stage has its own way of operating, its own operational semantic, if you would. Some might use CPUs, some would use GPUs, different levels of memory, and so forth. But they all want to have access to this common data pool so that you can leverage actions performed at the previous stage seamlessly, right, without having to build complex algorithms to share data across these systems. And that is one of the big use cases that a shared file access with an RWX access to your PVs enables. And it's not just that. You can think of a use case of auto scaling, right? As you need additional performance, as you need more pods, you could declaratively auto scale your pods, and all of them can continue using the same data pool or the same PVs with the RWX access, right? And this also extends to rolling updates. You can now upgrade a few of your pods to the newer version, while the older version and the newer version both continue access to the same PVs without having to, or the application having to face any downtime or outage, right? So and this is not this is a very small subset, right? So we believe that most enterprise applications are kind of built for shared access, right? It's not an exception, but a norm. And most homegrown apps will benefit out of this. And re-architecting them to a shared nothing architecture is a complex undertaking, which is totally unnecessary if your data platform can provide you the same level of shared access at a PV level, right? And better still, provide it in a Kubernetes native semantic where your operational simplicity comes in play. So we believe that the shared file access is a big proponent in increasing adoption of cloud native applications, especially bringing all these enterprise applications over to containers. Next, let's look at some of the other requirements of enterprise grade data platform that these applications require. So we've looked at this. We've talked about this. Kubernetes applications are composable. They're made of microservices, right? They're scalable, scalable through declarative API, and serve a global set of user base. So when you now think about your data storage or your data platform that needs to serve these apps, you need to kind of follow suit, right? And the same questions apply. How easy is it for your data storage to scale? How available is it? And how compliant is it? When you talk about scalability, can you do it through a declarative API? Can you easily operationally scale it? Can you survive commodity hardware failures? Because in most cases, this is going to be running on commodity hardware, right? And still continue to serve data without any kind of outage. And what are your compliance and regulatory requirements to serve this global user base? And these are all that an enterprise-grade storage platform or a data platform has built over a period of time, right? And now that's where we believe Astra Data Store brings the best of both worlds in terms of being Kubernetes native and providing the shared file access and enterprise-grade data management and the rich data services to your Kubernetes applications. Astra Data Store was specifically built for handling these use cases or these challenges and taking them head on. Our teams have been hard at work to redesign or build the Kubernetes native data service using the cloud native design patterns, but using the foundation of NetApp's mature enterprise data management technologies, which enterprises have come to trust over decades, right? So let's look at what that means to you, right? In terms of what it brings to your Kubernetes application, it is, first of all, Kubernetes native, and it brings the best of file. So what it means is you're now looking at a standard NFS protocol, right? Natively available to serve PVs without your applications or application pods having to rely on custom client software to do the shared file or shared access. Right, so it allows you to allow the same shared volumes to any application, and it is declarative. It is Kubernetes native, so you can scale it like you scale any other application. Right, you change your YAMLs, you reapply, and voila, you're good to go. So and that's the value prop, but you're not compromising on your data management resiliency, right? You're getting all of them that enterprises have sworn by, right, of years of service. And you're getting all of this with the native file service for both, not just your Kubernetes application, because it's a journey. If you've gone through this journey, you know that while applications are transitioning from VMs to containers, it doesn't happen overnight. It's a journey, and you still continue to have some VM workloads. So Astra Data Store brings in this unified service for both Kubernetes as well as VMs. And while eliminating your operational complexity, because it's Kubernetes native, so you don't have to learn a new way of deploying, managing a storage system, and it's built for auto-scaling and portability. So now let's look at how this all fits. So Astra Data Store is built for application-driven infrastructure. It is delivered to you as a Kubernetes application. It can run alongside your Kubernetes application in the same Kubernetes cluster in a converged mode, or it can run on its standalone Kubernetes cluster. You can adjust its resources like we talked about and scale it on demand or shrink it on demand as you see fit and as your use cases evolve over a period of time. You can run this on a physical server with a bare metal deployment of your Kubernetes cluster, or you can run it on a virtual server with a VM-based deployment, right? So bottom line is you can run Astra Data Store as you run your applications. It provides you the flexibility to run wherever, whenever you need it, right? Now, and not just that, it can also continue to serve while it's running as a Kubernetes application. It can continue to serve your existing VM workloads, right? So to summarize, what this actually means is you're getting the best of file and being Kubernetes native at a variety of deployment options and flexibility. So let's summarize and let's start with that. Best of file and Kubernetes native, providing you the deployment flexibility. So run it on physical, virtual, hyperconverged, standalone, big or small, whatever you wish, right? And second, simplicity. For those of you Kubernetes experts, you're new to storage management, you don't need to learn anything. It works the same way as your other applications do. It's controlled through kubectl. It provides you observability through native endpoints, open telemetry, Prometheus, also integrating with NetApp's own Cloud Insight and other monitoring and telemetry tools. Third, it provides you maturity. Your developers will be happy to know that they can now focus on the critical problems, their business logic, right? As opposed to figuring out how their apps interact with the storage system, or having to overcome deficiency in your data platform, right? It gives them the same storage efficiency that other application developers are used to in a VM environment, and security and compliance. So it brings that maturity to the table in a Kubernetes native way. And fourth, you can now trust your data platform to meet all your data protection and availability needs of your applications, right? So your apps can run wherever, whenever you want, and set up the SLAs or meet the SLAs of your organization, and provide you migration and portability characteristics that are best in class, built on the data fabric that NetApp is famed for, right? So that's all the goodness that Astra Data Store brings. Let's take a sneak peek at what it looks like, and then get our hands dirty. Let's look at a standard deployment of Astra Data Store. So this is a standard upstream Kubernetes cluster with Astra Datastore deployment. upstream Kubernetes cluster with Astra Datastore deployment. You see that there's a namespace Astra DS-system where Astra Datastore is deployed. Let's look a little under the hoods. So what you see is this is operator-based deployment. You do see some other controllers and services that are running to enable the data management functionality. And then you can use kubectl to manage, to actually monitor and manage your cluster. So this is the status of your deployment. It tells you a bunch of other things like version, serial number, etc. Astra DS cluster is your extension, which allows you to get this access. Let's look a little bit into the descriptive nature of Astra Datastore. So you do a describe on this. You will get to the details of how this was declared, primarily emphasizing the declarative nature of this. So if you go into the details, you see that most of the parameters are provided, right, are declared. So you have your number of nodes, you have what disks, what cache device you want, what is the capacity, number of CPUs per node, what are your disk filters. So this really allows you to declare what you want to do with it. And also when it's time to scale or shrink, you just have to change that and reapply the CR and you're good to go, right? So that makes management, day two operations of Astra Datastore really seamless with the kubectl operation. Let's now look at another extension to kubectl, which allows you to display all the volumes that are running or are provisioned out of Astra Datastore. In this case, you have 4 volumes already pre-provisioned of 8 gig each, right? That tells you that you can do all your operations with kubectl. We also have Trident running here, Astra Trident, which is your volume provisioner. Here in this case, it is using, if you're familiar with Trident, it uses a backend as Astra DS NAS in this case. It provides you additional details. You can go now check how the storage class is defined using the Trident CSI provider. But you could also check what this cluster is up to, right? So this cluster has a single storage class provisioned with Trident CSI being the provisioner. But now let's get into the more exciting stuff of getting the applications deployed. Let's look at this one is a standard Nginx application which has a pod which would mount your PV at /data. It uses an Nginx PVC in this case, and this is using a read-write many, the RWX, the shared file we've been talking about, access mode. Right, using the storage class Trident CSI. It's creating a 2 gig volume. In this case, it's a simple application. So let's go ahead and deploy this application, and you do a kubectl apply into the namespace web, and you notice that the deployment is created and the Nginx PVC is up. Basic deployment with just one pod and one PVC of Nginx. So in this case, you would have the PVC deployed as a read-write many. Let's actually go check that PVC out. And as you see, the PVC is set up. There's a volume and the RWX with 2 gigs coming out of the storage class. Let's look at what happened to the volume in Astra Datastore. From the 4 volumes, we now have another volume showing up, which is the 5th volume Nginx just created, 2 gigs, right? And it matches the same volume in PVC. And yeah, this is a single pod application, so it's running and happily using that RWX, PVC, and the volume. Let's go test that RWX. We talked about auto-scaling as one of the use cases of read-write many or shared file, which we've been talking about so far. So let's go scale this deployment to 3 pods. So we had 1 pod running. We're going to make our replica as 3. So this scales the deployment, and let's see while it goes through the scaling of creating 3 pods and getting them up and running. We do notice that 2 are already up and running and 1 is creating. Let's look at the PVC quickly to make sure that it didn't create additional PVCs, and they're all actually sharing the PVC through a shared file that's coming out of Astra Datastore. And the pod should be up at this point. So you see now that the pods are running on different nodes as well. So there is node 2 and node 4 in play here, and then we can actually do operations into that PVC and the same volume through these different nodes at the same time through the shared file or leveraging the shared file semantics. And let's do something fun now. Let's go use the pod deployed or running on node 2 and try and write something to that or create a file in that /data mount point where Nginx mounted this volume. So just getting that file created from a pod running on node 2. So that should be done. Let's go check it out. Can I read the same volume from a pod running on another node altogether? So in this case, I have this other pod. So I'm going to go execute ls command just to make sure Pebble is still saying hello to me. And let's see. Okay. And that should be it. And there you have it. So that's the shared file access in action. So let's summarize. With Astra Data Store, you can now run all your workloads on Kubernetes. With best-in-class shared file service offered natively, you don't need to compromise anymore. You can run your existing enterprise workloads with minimal or no changes in Kubernetes. If you know Kubernetes, you can now manage your storage on your own. You don't need to learn new tools or new ways of managing storage. Storage management is now just a kubectl away. And with the whole Astra portfolio integration, you get to provision and protect your data to meet your business continuity and SLAs of your organizations with integration with Astra Trident and Astra Control, right, to provide you end-to-end app data lifecycle management. Please visit us at cloud.netapp.com/Astra and register for an Astra Data Store preview today. Hope you enjoyed this session and hope you have a great CNDM day and KubeCon ahead. Thank you very much.